4 different types of factoring. We have GCF, so greatest common factor, which there are a couple on here that we'll do for greatest common factor. There's something I call difference of squares, and I definitely see 2 of those, I think. The one that we tend to use the most often is when there are 3 terms like this. I call it the asterisk type of factoring. And then the 4th kind is grouping, which there are actually no grouping problems on here, but you will eventually see grouping. Okay, but for today, we're just going to practice the 3 that I mentioned. Okay, so please make sure you guys write this stuff down just as practice. Let's start with GCF. Okay, so for GCF, we are going to do number 3 and number 6, and go ahead and put the letters GCF next to both of those. So for the 3 of you that came in late, if you turn the practice page, that one right there, turn it to the back. That's what we're doing right now. Okay, so greatest common factor, this is what you're supposed to do. You're supposed to look at these terms. It doesn't matter if there's 2 terms, 5 terms, whatever. You're supposed to look at them and tell me anything that they have in common. So if this is n squared and this is 10n, what do both of those terms have? They have an n, right? So whatever they have in common, you put that on your paper first. So just put the letter n there. And then next to it, you're going to start a set of parentheses. And inside these parentheses goes whatever's left over out of each of these terms if you take an n out of each of those terms. So if this is n squared, but I took an n out, what's left? Just n. Just n. If you had 2 of them here, but you took 1 of them out, don't you just have 1 left? Like n times n is n squared? Yeah? Yep. Okay. Bring down that plus sign. And then out of 10n, if I got rid of the n, what's left? The 10. That right there is done. That is what we call greatest common factor for factoring. Now to make sure that you did this right, this is how you check yourself. You multiply, you distribute. So you don't do this on your paper, just watch me, okay? If I take n times n, I get n squared. And if I take n times 10, you get 10n. Is that what we started with? Yes. So as long as you, like if you check yourself, multiply it out, and if you get the same thing you started with, you know you did it right. But this is the answer here. So factoring is the inverse of distributing. Okay? Are we okay? Whatever they had in common came out front, and then you just divided both of those terms by n to get what was left on the inside. That's what it is. Number 6, you have 4n squared and 24n. So what do 4 and 24 have in common? Like, what are they both divisible by? 4. Aren't they both divisible by 4? Okay, so put a 4 on your paper. Do they both contain the letter n? Okay, so they have a 4n in common. So 4n is called the greatest common factor. And then you start a set of parentheses and you do division. So you don't have to show this on your paper, but what I am doing to get what's in here is I'm taking each of these terms up here and I'm dividing by what I put out front. So what is 4 divided by 4? 1. And then if you had n squared, but we took an n out, there's an n left. You can just put n. I just put the 1 there because some people like to have the 1 there. But I don't ever usually show the 1. Bring down your plus sign. What's 24 divided by 4? 6. And if I had an n, but I took an n out, are there any n's left? Nope. So this is done. That right there is your answer. And then you can just check yourself by doing multiplication. So if I took 4n times n, I get 4n squared. And if I take 4n times 6, it's 24n. So I end up with the same thing I started with. Again, what I did out here, that's just a check. You guys don't have to do that. I'm just showing you how to double check and make sure you have the right answer on your paper. So those two are the only two just straight GCF problems. I don't know what I just did there. Okay, then my favorite is difference of squares because I feel like difference of squares is extremely simple if you know square roots, if you know your perfect squares. So number 4 is, I put DOS. Anytime you guys see me write DOS, that's difference of squares. And so is number 8. So we're going to do 4 and 8. Okay, now, how do I know that this is a difference of squares problem? Well, first thing, what does the word difference mean? Subtract. Do you guys see a subtraction sign there? Okay, so automatic, I see difference. The of squares means you should have two terms that are perfect squares. If you guys look at your factor sheet, see all the numbers that have the little stars next to them? 1, 4, 9, 16, 25, those are your perfect squares. Is 4 a perfect square? Is 25. Okay, so automatically I know this is a difference of squares and this is all you do. Super simple. You are going to have two sets of parentheses that are almost identical to each other. Take the square root of 4a squared. What's the square root of 4? So this one gets a 2 and this one gets a 2. The square root of a squared, you just cut that in half. So a. So this one gets an a and this one gets an a. So 2a and 2a. What's the square root of 25? So this one ends with 5 and this one ends with 5. What's the only thing that is different between the two sets of parentheses? One's addition and one is subtraction. If you take a positive 5 times a negative 5, that's the only way you'll get a negative 25, right? So that's how I know that they have to be one of each. You can't have two positives because then this would have been a plus sign. You can't have two negatives because that would be a plus sign. So all you have to do on difference of squares is take the square root of each term, stick a plus sign between one of them and a minus sign between the other. Does it matter which one is which? No. I tend to always put my plus first, then my minus, but in all honesty, it doesn't really matter. That one's done. 2a plus 5 times 2a minus 5. And you might think this is picky of me, but these two sets of parentheses have to be written side by side. You can't put one here and one underneath it because these two things are supposed to be multiplied together. Multiplication means side by side. So make sure that's how you show it. So let's try number 8. Two terms, minus sign between them. We know the square root of 9 and we know the square root of 16. What is the square root of 9? So each set of parentheses starts with 3. Cut the x squared in half. What would it be?
3x.
Yep, so this one gets a 3x and this one gets a 3x. And then what's the square root of 16? 4. You guys can do that on your calculator or just look at your factor sheet. All you have to do is look at the row of 16 and find the one that's the double number. So 3x plus 4 and 3x minus 4. That's it. 3x plus 4 times 3x minus 4. So GCF and difference of squares all done. Now problems 1, 5, and 7 are just straight asterisk problems. When you have asterisk problems, so when you see three terms like this, a squared term, just x or k or whatever the letter is in the middle, and then a constant at the end, that's called a trinomial. It's three terms. And if you see that, obviously the first question you're always supposed to ask yourself is, do all three terms have anything in common? Because if they did, we'd have to factor it out. Like we'd have to do a GCF first and then do an asterisk. But do these have anything in common, these three? Nope. Okay, so this is how you set it up. That's an asterisk, an X with a line through the center. Now make sure you're paying attention to this, especially if you did not have Algebra 1B last term. The number out front, which technically is a 1, times the number at the back. So this is A times C. 1 times negative 24 is what? That goes up top. So you put that at the top. Now the B value, which is the one in the middle, this one, B goes at the bottom. So negative 5 goes down here. You don't have to worry about putting the letter there, just the number.
And doesn't, like, can't you use 1 as the first one on the top two?
Yeah, that's what I'm going to do. So here and here, these two top pieces is A. So this 1 goes here and here. Now I like to also put the letter with it. So if this was k squared, this one would get a k and this one would get a k. I just go ahead and I like to have the letter. If it had been x squared, you'd see 1x, 1x. M squared, 1m, 1m. Okay, so here comes the fun part. You need to look at your factor sheet in this row. So everybody look at that blue sheet. Look at the row of 24. And you are going to see all the different factor pairs that make 24. Yeah, that's it. See these 4 pairs of numbers. Okay, out of these 4 pairs, which pair can also make a 5 with either addition or subtraction? The 3 and the 8. Okay, so this is what I know. 8 and 3 have to be my 2 numbers. But if they were 2 positives, a positive times a positive would be positive 24, right? If they were both negative, negative times negative would also be positive 24. So they cannot match each other. One of them has to be a positive and one has to be a negative. And it matters which one is which. I'm going to tell you the easiest way to do it. The bigger number out of these two has to match the bottom. So the bigger one is 8. And if the bottom's negative, the 8 has to be the negative number. Okay, so the bigger number has to match the bottom. So it's negative 8 and positive 3. Now to check yourself, you say, okay, is 3 times negative 8 negative 24? Yes. Is 3 plus negative 8 negative 5? Yep. So you multiply to get the top, you add to get the bottom. Your 2 sets of parentheses come from right here, the 2 sides. Even though they're written up and down, you're going to write them sideways. So what does this say? K plus 3? And what does the other one say? K minus 8? Those are your 2 sets of parentheses. Ooh, man. Hand slipped. K plus 3 times K minus 8. Does it matter which set of parentheses I put first? No. Does it matter if you had the minus 8 here and the plus 3 here? No. The only thing that matters is that your signs are right. Your signs and your numbers that you picked. Okay, let's do number 5. Ooh, this one's a little harder. Okay, so for problem number 5, go ahead and draw your asterisk. And then up top, remember up top is A times C. So the first number times the last number. What's 6 times negative 12? You might need to type that one in. Negative 72. Yeah, we'll do 2 last. There's a reason I'm saving number 2. You've got to do 2 things on number 2. Okay, then the number in the middle, the B, goes at the bottom. So what number is that if you don't see a number there? So it's negative 1, right? Negative 1 goes at the bottom. And then whatever number's out front, A, which is 6, goes here and here. And then I always cut the P squared in half. So I'd put a P here and a P here. And then you guys have to look at your factor sheet. Look at the row of 72. Oh, there's lots. Don't tell me. Is that all of them? 1, 2, 3, 4, 5, 6. Okay. All right. So once you look at your factor sheet and you see all these pairs of numbers, which pair would be, whether you added or subtracted, would be 1? 8 and 9. Those are the only 2 that would have somehow make a 1, right? Okay. So we know they're 8 and 9. If this is negative, you have to have 1 of each. We just talked about that in problem number 1, because the only way your product would be negative is if they're different. So positive times negative is negative. The bigger one, the 9, has to match the bottom. So the 9 is negative, and the 8 is the positive.
But the 2 on the side can be reduced.
Yes. Yes. So this one up here, when your number out front is a 1, they're always easier because you can't even, I mean, this technically isn't a fraction, but it looks like it, right? Because of how it's written. If the top number is a 1, you can't reduce that. 1/3, 1/8, it's never going to get made smaller. The problem is when you have something like a 6 or a 2 or a 3 up top, there's a really good chance that at least one or both sides will reduce. So you have to kind of treat them like they are fractions. What are 6 and 8 both divisible by? 2? I heard somebody say 2. Okay, so if you cut them both in half, what do you get? You get a 3p plus a 4. I don't have much room here. 3p plus 4. Because that's what you'd read it going up and down. So 3p plus 4. This one over here, what are 6 and 9 both divisible by? 3. So this would be 2. 6 divided by 3 is 2p. And then this is minus 3. So 2p minus 3. Don't worry, we'll see plenty of these again.
That's what I kept spelling over there for.
Now,
reducing.
this is what I like to do. Just to double check myself at the end, I don't do all the multiplication. I just look and I say, okay, is 3p times 2p 6p squared? Yes. Is 4 times negative 3 that negative 12 at the end? Yeah. So, I mean, if I can get these two to multiply and these two to multiply and they match, it's got to be right. Cool. Okay, let's try number 7. We got 3 terms. They don't have anything in common, so we just jump straight to the asterisk. We're going to do 4 times 1. What's 4 times 1?
4.
4?
Yeah.
What are you, I don't,
I used to write letters on
oh, it's A times C is up top. A times C is how to get the top number. And then the bottom is just B. So B is -5. That goes at the bottom. Your sides are A's. So the 4 out front goes here and here. And then, like I said, I always cut the variable in half. So this would get an X and this would get an X. Yeah, it's A times C up top, B at the bottom, and A on the sides. Now 4, when you look at the factor sheet, way fewer options. It's just 1 and 4 and 2 and 2. Well, what's the only pair that would somehow make a 5? 1 and 4. Now this time, the top number is positive. So if I made them both positive, I would get +4, but if I added them, would it be -5? No, it'd be +5. So they clearly cannot be two positives. Okay, but if it's one of each, wouldn't that be a negative number? They have to match each other. They're both negative. It's -1 and -4. They both have to be negative. And again, ask yourself, is -1 times -4 +4? Yes. If I add them, is it -5? Yes. This is when knowing your integer rules comes in. Like, it's super important. Knowing that two positives multiply together stay positive, two negatives turn positive, one of each would be negative. You got to know that stuff. That's pre-algebra stuff. That's like long time ago stuff. Will this side reduce over here? 4x minus 1? Nope. That one's going to stay the same. You can't make those any smaller. But this side over here, 4x minus 4. Can't they both be divided by 4? Yep. So 1x minus 1. 1x minus 1. So x minus 1 would be your other set of parentheses. So 4x minus 1 times x minus 1. And again, just watch real quick for me. 4x times x, 4x squared. -1 times -1, +1. As long as I get those two, the front and the back, I'm pretty confident that I did it right. So just check yourself at the end. I know a lot of you in math, once you're done with a problem, you just want to move on. You want to forget about it, but just check it real quick. It doesn't take long. Multiply, multiply, make sure it matches. Okay? We only have one problem left, and then we're going to be done for today. So we're going to go to number 2. The reason I saved number 2 for the end was because the very first thing I said to you was that anytime you are factoring, the very first question you really need to ask yourself is, do these have anything in common?
Yes.
They're all divisible by what?
2.
Okay, so watch. If they all have a 2 in common, we're going to do a GCF first. So I'm going to start with GCF, and then I'm going to do an asterisk problem. Okay, so if I take a 2 out of each of those terms, what's left out of this one? Just the n squared, right? What's left out of this? 4n. And then what's 6 divided by 2? 3. Now this is what you're going to do the asterisk on. That 2 will be in our final answer, but it is not needed right now for the asterisk. We're going to just go over here and we're going to say, okay, what's 1 times 3? The 4 goes at the bottom, and then we had 1n and 1n. This one's easy. There's only one way to make 3. Multiplying. Look at your row for 3. 1 and 3. No, there's only one way to make 3 with your factor sheet, multiplication. That's 1 times 3. And if you add 1 and 3, will you get 4?
Yes.
Okay, so they're both positives. So you've got n plus 1, and you've got n plus 3. Now that 2 that I pulled out front, that 2 doesn't disappear. That 2 stays out front. You got to leave it there. So not only do you have your 2 sets of parentheses, but you also have a GCF out front. I saved that one for last because you had to use 2 different types of factoring for that one problem. Now that was just a real quick, brief overview of 3 of the different types of factoring. Some of you that even had 1B last term, you should have been the most familiar with it. Hopefully the rest of you, even if you didn't have 1B, this looks familiar because you should have done this at some point. It may not have been taught with the asterisk. The asterisk is just really a way to organize the problem. But you still, like you guys still, when I went through high school, I can remember my teacher literally saying to me, how could I multiply to get negative 24 and add to get negative 5? Well, that's exactly what we did here. I just put it in a little asterisk. That was it, but it was still the same method. Okay, you guys will see lots more of this, but this is, like I said, this is just a quick review over factoring, and then tomorrow we'll have a different lesson, and you guys will keep seeing factoring pop up all term long.